So in the last class, we have already discussed about kinetic molecular theory. And today I will explain you the liquid pressure and gas pressure with the help of kinetic model. So first, little bit recapitulate that the kinetic molecular theory. Within the kinetic molecular theory, I said to you that matter consists of tiny particles, and these particles can be atom, molecules or ions, and in between the particles the space is there, and that space is known as intermolecular space, and in between the particles the force is there, and that force is known as intermolecular force. If the space increases, then what will happen? The force decreases, and when space decreases, then force then intermolecular force of attraction between the particles increases. And now what happens in these particles are in random motion, so they possess energy, and that energy is known as, that energy is what? That is the kinetic energy. More the motion, more will be the kinetic energy, and less the motion, less will be the kinetic energy. So already we have discussed. Now next, today's that we will discuss about the liquid pressure. In liquid pressure, so first we have to know what is the pressure. Pressure is the force exerted by the liquid particles due to its random motion per unit area on the side of the containing vessel. Actually what happens, the particles of the liquid are in random motion. They are continuously in the motion within the containing vessel, and they are randomly moving, they are continuously moving in all direction, and in doing so what happens, these liquids particles strike against the wall of the containing vessel and hence exert some kind of force. Now the force exerted by these particles per unit area on the side of the containing vessel of the liquid is known as the liquid pressure. So force exerted by the particles per unit area on the side of the containing vessel, that is known as the liquid pressure. Now what happens, if more the particles will strike per unit area, then the pressure will be more, and if less the particles will strike on the wall of the containing vessel per unit area, then the pressure will be less, because pressure is equal to force by area. In the same way, when gases are there, then we know that gases also move in all direction. The molecules of gas contained in a closed vessel are also not stationary. They are also moving randomly in all possible directions. And in doing so, the gas molecules also strike the side of the containing vessel. And when they strike the side of the containing vessel, at that time what will happen, they exert force. Now the force exerted per unit area on the side of the containing vessel causes the gas pressure, and so the force exerted per unit area on the side of the containing vessel either by the liquid or by the gas, that is what, that is the pressure. Now we will discuss that what is the effect of reducing the volume of a gas on pressure in a closed vessel. Okay. Can you see these diagrams? So here what happens, this is just like a syringe suppose, and here is a piston. Okay, with the help of the piston I can increase or decrease the volume of the gas inside this syringe. When I will compress, the volume decreases, and when I will move this piston up, then what will happen? The volume increases. Okay. Now, in this cylinder, what happens? 20 centimeter cube of air is there, and here the pressure is 1 atmospheric pressure. With this manometer, we will measure the pressure, that the pressure is 1 atmosphere. Now what happens? I will reduce the volume from 20 centimeter cube to 10 centimeter, is half. When I will make it half, I will observe that the pressure becomes double, that is 1520 millimeter of mercury. Now why this happened? Actually, when the volume was this much, the number of particles which will strike per unit area of the wall, that is less. And when I will compress, then the particles come closer, so the number of particles which will strike per unit area of the wall increases. Here, if suppose the two particles are striking per unit area of the wall, here what will happen? Since the volume reduces, particles come closer, so 4 particles will strike. So when 2 particles will strike here, and here the 4 particles are striking per unit area, then what will happen? 4 particles are striking, so here what will happen is the number of particles striking will be more, so the pressure will be more. And here the number of particles that will strike will be less, so the pressure will be less. So here it means when I will reduce the volume, then the pressure increases. Why? Because when I will reduce the volume, at that time the number of particles that will strike to the containing vessel increases, strike to the wall of the containing vessel per unit area increases, and that is why the pressure increases. So now see what is written in your book. Let's see. When the gas is compressed to half its initial volume, the number of molecules per unit volume of the gas also becomes double. When I will reduce the pressure, then the number of molecules per unit volume, that will become double. Thus, the double the number of molecules strike against the side of the enclosed vessel, and thereby exerting double the amount of force. As the force acting per unit area on the side of the containing vessel doubles, therefore the pressure of the enclosed gas doubles. Conversely, if the volume of the enclosed gas is doubled, means from here if I will increase the volume, then what will happen? Then the number of molecules per unit volume of the gas will become half. Number of particles per unit volume of the gas will become half, and as the number of molecules strike against the side of enclosed vessel become half, therefore they exert half the amount of force. As the force acting per unit area on the side of the containing vessel become half, therefore the pressure of the enclosed gas become half. Now next is that explanation of heat conduction on kinetic model of matter. Means now we will explain the the mode of heat transfer, that is a conduction and convection by kinetic model of matter. Heat can be transferred from one place to another by 3 mode, that is, I think, conduction, convection and radiation. Conduction. This is the mode of heat transmission of heat energy from one atom to another atom in a direction from lower temperature in a direction of lower temperature without the actual movement of atom from their mean position is called conduction. In conduction, suppose an iron rod I want to heat, then what we generally do? Then iron rod is there, iron rod, I will keep it here near the, suppose here the flame is there, I will keep it here. Then what will happen? Slowly the heat will transfer from one particle to another particle, and then this part also become heated. This part also become hot. So here heat is transferred. So the mode of transport, but the particles are not moving here. So that is what conduction. Actually here what happens, when a solid is heated from one end in fire, then what happens, the atoms will absorb heat energy. When they will absorb heat energy, then due to the absorption of heat energy, their kinetic energy increases, and when their kinetic energy increases, then they vibrate about their mean position with more amplitude. And when they vibrate with more amplitude, what will happen, they will strike against the neighboring atom, means the nearby atom, and transfer part of energy to the nearby atom. Then that particle now vibrate with a large amplitude because its kinetic energy increases, and when it will vibrate with greater amplitude, then it will strike the neighboring particle and then transfer the energy to the next particle. In the same way, that particle also transfer the energy to the next particle. So in this way, what will happen, in this way, more and more atoms along the length of the conductor gain kinetic energy, and hence the temperature of the conductor rises. Thus, the heat energy is transmitted by conduction without the actual visible movement of atom of the conductor. So, in case of conduction, the actual movement of the particles won't take place. Only the energy is transferred from one particle to another particles due to the vibration of the particles. And it takes place in case of solid. The mode of heat transfer in case of solid is by conduction. Now next one is that heat convection explained on the basis of kinetic model of matter. Kinetic means due to movement of the particles or due to motion, the energy passes by the particles known as kinetic energy. So the phenomenon due to which the particles of a medium actually move towards the source of heat energy and then on absorbing heat energy move away from it, thereby making a space for other particles of medium to move towards the source of heat, is called the convection. Convection here, actually it is also a mode of heat transfer. Here the transfer of heat from one place to another place takes place by the movement of the particles, because the particles carry the energy and then transfer it to the region of lower temperature. So suppose a gas or a liquid, when it is heated, then what happens, the temperature of that part, means the part which is in contact with the heat, the temperature of that part increases, and when temperature of that part increases, then kinetic energy due to absorption of heat energy, the kinetic energy increases. Now when kinetic energy increases, then what will happen, they will vibrate more vigorously or their movement increases, and these energetic particles move away from the source of heat and rise upward. Again, this, when these particles rise upward, this result in fall in pressure, where the lower part. So to equalize the pressure, what happens, the particles of the liquid from the colder region, means the upper part, move down, the upper part move down or sink down and move towards the source of heat. This in turn give rise to convection current. So this is what convection. In convection, what will happen? Again, I am explaining to you that what happens when the liquid or any gaseous substance, when it is heated, then the particles which are in close contact with the heat. Suppose these are the liquid particles. When they are heated, here heat is provided with the source. When they are heated, then these particles which are nearby the fire or the flame, they absorb heat. When they absorb heat, then their kinetic energy increases, then they will move vigorously and these energetic particles, then they will move away, they become lighter also, so they will move away from here to the upper region, they will move away. Okay, they will move away, but here the pressure decreases since the movement of these particles, the pressure decreases here. So to equalize the pressure, what happens, from here the particles move down. Again these particles heated and they become energetic and their movement become faster, so they move up. Again to equalize, here the pressure decreases. To equalize the pressure, again the particles come down, and this is what, this is convection, where the transfer of heat taking place from this region to this region, from one region, that is this, to another region, by the movement of the particles. So heat convection also we can explain with the help of the kinetic model of the matter. So this is all about your this chapter.